If you're not localizing sounds, then following a recovery of your acoustic files from the recorder and conversion to WAV files with the SPR utility, you are ready for data analysis. But if you're using an array of recorders, then you will typically have to merge the single channel WAV files created by each recorder into a multi-channel WAV file comprising the recordings of all recorders, each as one channel. In this case here, recorder 1011, 1012, 1014, and 1015. You do that with a utility called wavmerge, W-A-V-merge, a WAV file merge utility, and it is a command line utility, just like SPR is. So you have to call up CMD. In this case, it's fine to left click, or you can right click. You don't have to run it as administrator. And now you go into the folder into which you unzipped your wavmerge utility after you got it from the Desert Star website, or it would already be on your machine if you received a computer from Desert Star. So I'm going to go to the folder, and it's typically just on your C drive under wavmerge. And if I enter the command here, then I get all the options. Here you can see input files, output files, and so on and so forth. Now in this particular case, our data, acoustic data, is on drive E in a folder called Minesto. And so here you see a few examples of how to select your file. In our case here, we say wavmerge, and then the input path for us is E Minesto. Let's say in this case we want to convert all WAV files that are in here. So star.wav, the star's wildcard, so anything that's in there, anything in that name .wav would be accepted. And then the output, we're gonna put again in Minesto in a subfolder called merged, and we're gonna name it m-star.wav, meaning we are preceding the file name with the m- just to indicate it's a merged file. The next thing is important. We have to specify the minutes per output file. Our input files are 15 minutes, and I'll make the output file 15 minutes as well. But where that's important is that the maximum file size that is possible in a WAV file is 4 GB. And so you have to make sure that your merged file will not exceed 4 GB. For example, these 15-minute files, they're about half a gigabyte each, 4 channels is 2 GB. If there were 1 hour files, then each file, input file would be 2 GB and the output would be 6 GB. That wouldn't work. So rather than saying 60 minutes, I would select 30 minutes or 15 minutes as my merged file length. So what will happen if, for example, my input recording files are 60 minutes each and I specify 15-minute output files, then the 60-minute recording segment, each 60-minute recording segment will be split into 4 15-minute output files, and consequently the size of the output file containing all 4 channels, of course, is reduced accordingly, thereby staying under my 4 GB limit for a WAV file. Next thing I need to specify is what my recorder channels are, and I have 1011, 1012, 1014, and 1015 are the 4 recorders, And the first one I specify will become 5. And that's it. Now I just hit enter and the merge process should start then. Okay, files to be merged are eMinesto star.wave, and these are the output files. Merged file segment length will be 15 minutes. There are 4 recording channels, and now it's initializing a file merge list, building the merge list, and now it's merging segment 1 of 20. Let's see how fast the merge process is going. We'll wait for the start of the next merge segment here. We are now at 55 seconds. And now we are at 33 seconds. So it took a total of 38 seconds to convert a 15-minute set of files. Converting 15 minutes in 38 seconds is about a factor of 24 to 1. So it takes 1/24 the time to merge these files as it took you to record them. This is at a sample rate of 300 kilohertz. It would be faster if you're sampling slower, or slower if you're sampling faster. Now, 1/24 of, say, a month's worth of recording is still over a day just to perform the merge operation. So again, you might want to optimize your computer for speed of merging. And that would be using a fast processor, a lot of memory, USB 3 ports, if it's affordable, solid state drives instead of hard disk drives. Very similar to what you would be doing to optimize the speed of the initial file reading and conversion to WAV file. And I recommend that you experiment a little bit first before, say, investing in a large stack of expensive solid state drives. See how you can get the speed that suits the need of your project. Now we are coming up soon here at the end of our merge operation. All right, and with this, the merging is done, and it says it published a merge list. The merge table is here, and let's see if we can find that now. So here are our merged files, and you can see each one of them is 2 GB long, comparing to the input files, which are 524 megabyte. So the merged files are 4 times as big each because they contain all 4 channels. Finally, we find this CSV file. I will open that here in Excel. So here you see the result. We have the date stamps that it identified and the time stamps. You can see that's in 15-minute intervals. Here you find the files that wavmerge found for each channel. Channel 1, 2, 3, and 4. And then this is the name of the merged output file. Now you might find, depending on what's going on, that maybe you have some data holes here. You know, there's a file missing in one channel or another. So the merge table is a very good capability or report to have a quick look at how your file merging succeeded, what was available to it. If you do have data holes here, then look in your report of the original file recovery, look at that tutorial video and check if they're there so that you can see where in your processing chain, you know, recording, recovery of recorded files, merging, where in the processing chain you might be losing some of your data here. The next step beyond this is to start your data analysis.